Hello. Streaming. Are we streaming? I guess we're streaming. Good evening, 17th of the 10th, 2019. Nearly 9 o'clock. Just trying to find the stream. So we're streaming. There we are. Alright, just gonna mute this. We're streaming. Let's take this down to a small amount of stuff. Yeah. So we're streaming. There we are. Right, just let that catch up, that's it, yeah. Okay. Oh. Turn that off. There you are. Let's just refresh that. Turn the mute sound off. Okay. Right, hello. 1, 2, hello, we're streaming. Big deal, eh? Never mind. Right. What have we got? Let's just try to shrink this a bit. No, that's shrunk already. Can't see. Doesn't really show you what's going on, never mind. Hi, Amigans. Hi, Amigans. Okay, deny Amigans. What we got today? And I've got. Hang on, you can't even see because there's a great big cable in the way. Wait on them. Yeah, lots of cables in the way. Sorry. Still lots of cables in the way. Can't really do much about them. Or can I? There's lots of cables in the way. Sorry about that. Right, how's that? Still cables in the way. Too many cables. Sorry about the cables. Right. Anyway. We've got cables over here now. Sorry. Got cables everywhere. Damn cables, eh? Right. Okay. Now I seem to be not streaming, do I? Am I streaming? Yeah. It's gone to 480p. Right. Okay, now hello Amigans. We've got here a. You seen one of them, haven't you? Let's get on the back view a minute. Rear view. We've got ourselves a eBay purchase. It's a PSU for an Amiga A600. PSU for Amiga 600. Little bit of a low profile one, lightweight, faulty. But I haven't even tried it, but it's supposed to be faulty. And shall we give it a go? Smells a bit arsenic-y. We get back down to this one. Right, here we go then. So the first problem we're going to get is we're going to get a problem of can't get it open. Let's have a look at that. Yeah, plug looks good. Let's see if we can get it open. Now I know this one is a funny slotted screwdriver. I've got a feeling it is. Not too sure. Can we see inside there? Let's have a look. Let's just undo this one a minute. Bear with me. Just bear with me, please. Oh well, it's not as bad as I thought. Let's just try to focus that in a bit. Let's get you on the bigger view. Focus in. Okay, what we got here? Is that some kind of security screw? So it's like a lump in the middle, and that's a weird one, isn't it? Oh, I see. So you need a bit of a flat bladed with a slot in the middle. So how are we going to open that then, I wonder? I don't think I've got one of those handy. Right. Hold on a second. Let's just put that one away back in its holster. Okay. Right. Did I buy any? Did I actually buy any screwdrivers that'll do such a thing? I can't remember. I don't think so. Right, let's have another look in here. Have I got a security torque bits? Anything like that? I don't think so. Can't remember seeing anything like that. So let's just try a normal one, normal screwdriver. No chance. Oh, hang on. Oh, that seems to have caught hold. That seems to have caught hold of it. Right. Okay, so for some reason I was able to undo that screw. And this one. Now look at that. I thought that was going to be very difficult. Okay, so that's alright, that's good. That's good. 7 minutes and we're just taking the screws off. So I suppose I should test it really, but I think I'll have a look first to see if there's anything obvious. I think I plugged it in. I can't remember now. I think I plugged it in and put the meter on it, but I cannot quite remember. So let's take it apart and have a look what it's like inside. See if there's anything we can fix in this. So this might be a regular occurrence, this streaming live. Streaming live, what about streaming live? Do we like streaming live? I don't know. We'll give it a go. We shall give it a go for a while and see if anything good. At least it saves having to upload the video later. See if any screws pop out. Oh, yes. That's a good sign. No black in the lid. So that is a good sign. That's quite a nice looking plastics for an Amiga power supply. Not yellowed, but it is one of the later models. And that's the reason I bought it. I wasn't really bothered if it didn't work. You got the money's worth in the plastics. Right, this is where I've got to take my glasses off. Can't see with close up with them, huh? Right, so we've got a fuse we can see straight away. Let's take the screws out the way, they're dropping out. all over the place. So, why aren't there loads of people watching? It's probably because it's boring. That'll be it, and plus nobody knows I even exist, so anyway. Right, 4 screws, put them to one side, somewhere out of the way. Let's have a look at this. Let's have a look at the bottom of the board, let's get it out. So it's screwed down even. This one is even screwed down on its own. It's the first time I've seen one that's screwed down as well as fastened in. Right, how am I going to get that out? Tweezers. To go in metal tweezers without earthing the ground and the capacitors? Dangerous. Never mind. Just make sure you got the other end not plugged in. Hang on, let's have a look. Ah, it's alright. It's alright, it's not plugged in. Oh yeah, don't do this at home. Don't do this. Don't mess around with electrics. Don't do as I do as I say. Well, here we come. Right, let's have another look. Right, no black. Good sign. No black. No burn. Okay. So, is this going to be a simple fuse problem? Let's take a look under the board. What we got there? Anything? Any dry joints? Can't see any offhand. Doesn't look like any dry joints. So there's one. What is that? That's alright, it's only a heatsink stand. So there's no cracks on the PCB. There's no apparent dry joints. That's a good sign. Right, let's try the fuse. So I'll put the old let's go on to ohms, is it? Continuity check. Right, we're on a continuity check now. Let's just see if you can see anything. Continuity check. Why no continuity? Oh, there it is. Not sure I like that one, but anyway. Right, let's have a look. We got continuity. Sorry you can't see. Sorry I told you that. Yeah, 1.7 ohms, so it's close. It's a bit high really, but why is it so high? Ah, that's better. So that's not a problem. Now, has it even got a problem? Purchased not working. Do you think it's really not working, or is it people haven't got the equipment to test it? So what we'll do now is we'll switch it on. Tell you what I'll do now, I'll just rest it on my hand. No, I'm not going to do that, because that capacitor there, see that one there that says danger? Danger high voltage. This is a high voltage side of the DC. It's switch mode power supply. This side's low voltage, this one high voltage. Shall we measure the... Let's measure the capacitor, see if it's got any voltage left in it. Right, back on volts. Let's see if there's anything left in this capacitor. There it is, across there, ready? What we got? Nothing. Nothing but a few millivolts. Yeah, so we're okay to touch that. Right. I'm going to put it back in the base. Back in the base, just to keep it off the deck, so I can stop it from right. Let's plug it in. Shall we check the fuse? No, we won't check the fuse. Well, I'm going to plug this in. Is it in? It's in. We're in. Of course, there's no LEDs on these supplies. No, all expense is spared with these. No power LED or anything. So, we're going to have to measure this socket. Oh, I've got to get up an Amiga plug, PSU plug, wiring. Let's get some wiring. Okay, that'll do. So according to this, ground is upper right. Is the shield ground as well? I'm not sure. Right, so according to this is going to be awkward, isn't it? Trying to hold this still, you can't even see, can you? Okay. So we're on the volts. According to this one here is no, it's going to be awkward to hold this still. It's going to be very awkward to hold this still without shorting it out and getting electrocuted at the same time. Yes, to hold still. You can't even see, can you? Alright, I don't want to short out the ground to this frame, so I've got to be careful. Alright, what's the next one? What's the 12 volt? Let's see if we've got 12 volt. So that one and that one should give us 12 volt. 2.7 millivolts. So that's not a good sign. The middle one is minus 12 volts. No minus 12 volts. Bottom right 5 volts. No 5 volts. Shield, that's just shield. So hang on, don't forget to switch it on. Yeah. See that little black switch there? You got to switch that on before you get anything. Right, now I don't like switching it on. I definitely don't like switching it on. So I'll switch it on while it's unplugged and then plug it in. Or switch it on. Here we go. You might get a bang there, hopefully not. Right, can hear the windings squealing. So it's doing something. Right. You even still there? Yeah. Let's go for the... Yeah, we're okay. Right, let's try that again. This is the problem with going live. Here we go. Right, how can I hold that still again? Somewhere where you can see it. This is a nightmare, isn't it? Right. Let's just hope I don't get my fingers tangling in the power supply. Right, this is supposed to be... Oh god, this is awful. Should clamp it down really. Why don't I clamp it down? Tell you what, let's clamp it down. Why didn't I think of that? Everything falls down, never mind. Okay, well let's even clamp this down. This is my PCB clamp. This is going to take a while. That was a bad idea. I'll tell you what will this do? Basically hold it still for me, that's it. This is a nightmare. This is lesson in kind of how not to do a live stream. Do not do a live stream this way. Right, here we go. Now these Amigas are deadly supplies, by the way. I've had a dead short of the 12 volts on an Amiga 600 main board, and instead of blowing a fuse or blowing a supply or shutting down, it just went off like a Roman candle. Basically, it's just glowing red like a cigarette lighter, and just burning away till its heart's content. This is no good. Take that away. That's no good. Steel and electrics don't work. Yeah, steel and electrics not a good idea. Right, anyway, nobody said this was going to be easy. Right, here we go again. I had it the first time, didn't I? Oh dear, sorry. What if I try different probes? I hate swapping probes. Right. God. Sorry. This is so awkward. Whoever said this was supposed to be a nice, stressful live stream, this. I can't do it like that. Hang on. I've got to find some probes. Right, probes. Where are your probes? Probes. Yeah, you gotta get probes that you can fit. Why is this turning out to be silly? Helping hands. Okay, let's try some helping hands. Right, here we go. Helping hands. Let's get rid of that bit. Hello, helping hands. Can you help me? I'm a Dalek. I need some Arduinos. That poor lad. I made him say. I said, just say it. Say, I'm a Dalek. I need some Arduinos. He must have thought, what the hell is an Arduino? Right. They're fiddly things, aren't they? Right, what we got now? So, let's see if you can see the plug now. Yeah, let's just hope we don't. Okay. Right, here we go. How many minutes? 22 minutes to do a test on a thing. Well, now. That's probably why people edit stuff, isn't it? Right, so you got ground and you got 5 volts. Have we anything? 1 volt. Ground and 5 volts supposed to be. 1.6 volts. Ground and 12 volts. Got milliamps. Ground and minus 12 volts. We're not doing good at all, are we? Oh, does that look minus? Is that minus 12 volts then? It's all over the place, isn't it? How can you diagnose stuff with stuff that's all over the place? That doesn't tell me nothing. But if I cracked out the AVO, it'd tell me straight away. Okay, let's just try this one. Let's try this one. Try a different meter. Fluke. Can't go wrong with a fluke. Don't go wrong with that. You get a fluke, eh? Right, it's like doing a dentistry or something. What we got? Can't see it. Hands anyway. 1 point some volts. 1 point some overload. Even this one's doing a mess around, doing its overload and range swapping. 1 point some volts. Right, so we tried that. Let's try something else. Let's try an Avo. Hold on a second. Let's try an Avo. Let's try an Avo. Right, it's going to take some putting on the desk, isn't it? Good God. Hang on. Right, we got an Avo. Let's. It's had new batteries recently. Right, how am I going to do this? How am I going to do this? You can't push these into old Avos. They don't go in. So let me find a couple of probe wires. They'll go into an Avo. Right, what's this one? That'll go in. That'll go in. And what else? Yeah, these two are going to an Avo. You can't see. Sorry. Sorry. It's a live stream for you. Hello, I'm back. I'm back. Let's get some probes into this Avo. Common. Alright, so we want DC volts. DC volts, where are you? Milliamps. DC. Okay, so DC volts, AC volts, DC volt, DC amps, milliamps, DC volts. Okay, so what are we expecting? 30 volt range should do. Let's just give it a test. How do you test this thing? I don't know how you test this thing, man. Pots are very stiff. Is it even on? Oh, I can't. Let's stick it into 5 volts, see if we get anything on the power supply here. What we got? 30 volt range, looks about 5 volts to me. Right, let's see if we got anything. I've been so long using digital meters, I forgot how to use a blooming Avo. Anyway, right, what's that? Nothing there. Nothing there. Oh, what's that? 1 volt odd. Yeah, so we've definitely got a problem. Okay, let's turn that off. Get rid of the Avo. Put the Avo out the way. Get rid of the Avo out the way. Okay, so let's get rid of that out the way. That's out the way. So we're back to the yes. Oh, got a slightly bloated capacitor there. That's not good. Right. So how are we going to test this? So we tested it. We definitely know it's not working. I suppose we ought to see if we got DC going to it, some live and neutral. Yeah. Let's get another meter on it. Whoops. Right, we're on, what are we on? Volts. Do we have to go on AC volts? Let's have a look. No, that's fine. Right, let's do some probing. So the first thing we want to see is if we've got any volts going to hello, you still there? Yeah, I'm sure. Right, let's just do some live. What we got? Anything? Where's our volts? Why haven't I got no volts there? I've got no input volts at all. I've got no mains input. So I think I'm going to test the fuse and the plug. Let's just, oh, we had a squeal out of it though, must have had some voltage. Right, let's go on to continuity. Continuity on the live. Let's test the neutral first. So, neutral. Go on, bleep. I want this work. What's the matter with this thing? So we've got neutral. Let's try the live. Yeah, we've got live. We've got live. Yeah, we got live going through. That's good. Alright, let's see if we've charged that capacitor up now. Back to volts. So we've had power on this board and it was squealing a little bit. So let's see if there's any power on this high voltage capacitor. 410 millivolts, so still no power on it. Right, so I'm going to have to power it up like that, aren't I? Right, I'm going to have to plug it in. I have to plug it in, hope it doesn't fall off the desk. No, hopefully it's going to happen, isn't it? There you go then. Right, yeah. Back on volts. Let's see if we got anything. Doesn't like that. So this is a Handtech. This Handtech USB data logger volt meter. You put your probe on. See that? Did you hear that? It disconnected my meter from me then. I don't think this is very well isolated, this thing, so I'm going to abandon using that for this live test. Let's get back on the meter. I don't know the way it just turned off one of my USB ports. So let's do another test. So we're on this one. You can't see. There we go. Let's have a look. We're on volts. Let's have a look what we got here. Minus 300 volts, so we're on DC. We've been rectified. 335 volts DC. So we've got the right amount of DC coming into the coil this side. Let's see if we got anything coming over this side. Let's say that one's the ground. Let's try that one. 1 volt AC. I'm not sure which is ground on this. That's ground. Definitely ground there because the capacitor minus goes to that. Right, 0.4 of a volt, 1 point some volt AC. Right, so so we're not getting any high voltage through a bridge rectifier. Let's go back over here. So we know that's minus, that's plus. Yeah, no, it's not. It's the other way around. Down to here. Let's have a look at this. Nothing there. 4 volts AC. 300 volts. Some weird frequency test. All this line is quite high powered here. Right, let's switch that off. Just a matter of interest, see how quick this drops down. You can't even see it. Nothing? No. Okay, so what do we know? We've got AC volts going in. AC volts going in to this side of this. 300 volts. So we're not getting any switching doing, are we? Nothing's happening on the switching scene. And can I see? Yes, I can see a problem down there. Is that a problem I can see? Let's have a look at that. Let's get the scope out a minute. Hold on. I think I can see the chip blowing apart. Let's just see if it is, or is it just a bit of fluff? No, it's not blowing apart, is it? Oops, sorry. Is that a blown chip, or is it just a bit of heatsink compound? It's just some heatsink compound, that is. Yeah, it's just a bit of heatsink compound. Might as well have a look round while we're here. Bit of dust in there. So this looks like it's going to be a repair for another day, this one. Going to need to get the schematic out for this one probably. There's nothing showing 7812 voltage regulator there. What's that one? I don't know what that one is. What's that one there? No, it's not too good, is it? Anyway. Right, so that's gonna we've had a look at it. And that's gonna need to be a bit more in-depth look at that. So that's a bit of a fail. Not an easy fix at the minute. Not an easy fix at the minute. Not that bothered. Mainly the case and the leads that I wanted out of that deal. So maybe I'll make a circuit board that goes in that. Right, what else we got? Have we got anything else? 39 minutes. Well, I think that'll do for now. I'll leave that one with you. I think that's one for the trash bin, I think. Anyway, anyone watching, thanks for watching, and that'll be the end of that. Thumbs down on that one, gotta be. Okay.